On the surface, the universe appears to be a calm and static infinity, but in fact, there is an epic story around every corner. But what if the Milky Way, our galaxy, is like a monster, devouring other galaxies to satisfy its hunger? This is the story of what our galaxy has done to grow, and what secrets it has uncovered in the process. There is great chaos in the universe, swirling behind a quiet order. Today, we will explore the Milky Way's battle for dominance over other galaxies, the traces of that battle and key events in the evolution of our galaxy. This will shed light on our galactic history and help us understand our place as humanity in the universe. Although the Milky Way is romantically described as our galaxy, it actually moves silently through the depths of the universe like a dark predator. Some 13 billion years ago, it was a shapeless cloud of gas and stars in the vacuum of an expanding universe. This chaotic and raw beginning laid the foundation for its eventual transformation into a majestic galaxy. But this process was not limited to growing on its own. The Milky Way acted like a predator, eyeing the smaller galaxies around it. When the universe was young, galaxies were much closer together, and this proximity meant that collisions and mergers were almost commonplace. Each merger made the Milky Way stronger. It was engulfing the smaller galaxies around it, pulling them in and swallowing them up with its gravitational pull. This cosmic dance was one of the most important factors determining the future structure of our galaxy in the early universe. The youth and dynamic nature of the universe meant that interactions between galaxies were much more intense. Galaxies collided and merged frequently, and each merger caused massive bursts of energy and the formation of new stars. This chaotic dance shaped the cosmic order of the universe, allowing galaxies like the Milky Way to take on the majestic shape they have today. Each collision rearranged clouds of gas and dust, triggering starbirths and multiplying the growth rate of galaxies. Galaxy mergers at the time were not only destructive but also creative, and these processes laid the foundation for the Milky Way to become a giant. The chaos of those early days set the stage for the Milky Way to become the majestic structure it is today. The Milky Way was skillfully using its gravitational pull against the smaller galaxies around it. This process was like a cosmic predator stalking and waiting for its targets. As the smaller galaxies were caught in the Milky Way's powerful gravitational field, they found themselves drifting towards an inevitable end, like leaves being sucked into a vortex. Each one was losing its stars and gas clouds and merging into the growing body of the Milky Way. These mergers created not only a physical but also a chemical transformation. The birth of new stars and the reshaping of gas and dust clouds became part of the cosmic dance. The Milky Way absorbed these smaller galaxies around it with the precision of an artist, and each merger left a unique signature in the fabric of the galaxy. Each merger sent the Milky Way into a cycle of rebirth. As colliding galaxies plunged into cosmic chaos, the bursts of energy from these mergers were incubating new stars. Clouds of gas and dust provided the building blocks needed to reshape the galaxy. The massive energy releases of the stars scattered this cosmic material around, allowing the Milky Way to take on an even more complex and richer structure. This process was not only a physical rearrangement, but also a rewriting of the galaxy's chemical composition. Smaller galaxies around the Milky Way brought their own unique elements and stars, adding a new dimension to the growing body of our galaxy. This process of collision and merger was one of the most creative and impressive moments in galactic history. We can still see traces of this cosmic dance today. They are a kind of cosmic map of the Milky Way's history, revealing our galaxy's past stories of mergers and collisions. As stellar streams glide like thin threads through the depths of space, the remnants of stars from swallowed galaxies persist as souvenirs of this gigantic dance. Each stream is a testament to the Milky Way's greed, but also an example of the complex and poetic order of the universe. These traces of the universe allow us to understand how our galaxy grew, which galaxies it merged with, and what it gained in the process. Like a detective story, by following these traces, we can reconstruct the evolutionary journey of the Milky Way, even today this process continues. The Sagittarius Dwarf Galaxy is one of the Milky Way's victims. Sagittarius, a small galaxy, is slowly being torn apart by the powerful gravitational field of the Milky Way. In the process, the galaxy's stars and clouds of gas and dust mix into the Milky Way's spiral arms and form structures called streams of stars. These streams of stars are one of the most tangible evidences of cosmic cannibalism. There are many such streams in the observable universe, and each one carries the remnants of structures that were once independent galaxies. The swallowing of Sagittarius represents not only the loss of a galaxy, but also a new contribution to the evolution of the Milky Way. This process shapes the motion of stars and affects the distribution of dark matter. Stellar streams are cosmic signatures documenting the Milky Way's hunger for growth. These thin stellar chains are formed by the arrangement of stars left over from swallowed galaxies. Space observatories like Gaia are mapping these stellar streams, allowing us to better understand the Milky Way's past. For example, a structure called the Helmi Current contains the remnants of a galaxy that was swallowed about 10 billion years ago. Such structures are cosmic relics that write the history of our galaxy. These currents, which lie in the Milky Way's outer halo, reveal which galaxies our galaxy has swallowed in the past. The future of the Milky Way is full of equally dramatic events. In about 4.5 billion years, the Milky Way will collide with the Andromeda Galaxy. This event will result in the two galaxies merging to form a gigantic elliptical galaxy. Scientists call this new structure Milkomeda. Although direct star collisions are rare during such galaxy collisions, the interaction of gas and dust clouds can give birth to new stars. This event shows that galaxies are not only destructive but also creative. Dark matter is an invisible hero in the story of the Milky Way's growth. Dark matter acts as a skeleton around galaxies and accelerates their merger processes. When galaxies like Sagittarius are swallowed up, their dark matter halo structures are added to the Milky Way. Dark matter strengthens the gravitational pull of our galaxy, allowing the spiral arms to become more pronounced. It also affects the motion and distribution of stars around our galaxy, proving that evolution is a complex cycle. The growth of the Milky Way shaped not only the structure of our galaxy, but also life on Earth. Heavy elements from ingested galaxies played a critical role in the formation of the solar system and rocky planets like Earth. Without these elements, life might not have been possible. The Milky Way continues to grow, acting like a cannibal on a cosmic scale. This process is not only part of the evolutionary story of our galaxy, but also a guide to understanding the complex workings of the universe. Cosmic cannibalism reveals that galaxies are not only gigantic building blocks, but also dynamic entities that contribute to the constant transformation of the universe. The Milky Way's greed has increased not only its physical size, but also its chemical richness. Each swallowed galaxy has added a new story, a new element to the fabric of the Milky Way. Many of the stars and planets we see around us today are the products of these cosmic mergers. For example, stars traveling in the spiral arms of our galaxy bear the traces of these processes and whisper to us about the chaotic nature of billions of years ago. Beyond that, cosmic cannibalism allows us not only to understand the past, but also to predict the future. The inevitable collision with Andromeda suggests that the Milky Way will once again undergo a massive transformation. This merger will shape the fate not only of the two galaxies, but also of the billions of stars and planetary systems they contain. This giant future merger will give our galaxy a new identity and lead to the birth of a giant galaxy called Milkomeda. Finally, this evolutionary journey of our galaxy helps us better understand our place in the universe and our origins. On a cosmic scale, the size and complexity of our galaxy holds a mirror to the constant transformation of the universe. Future galactic mergers and discoveries will offer new opportunities to unlock the secrets of the universe and bring humanity one step closer to the stars.